Welcome to the deep dive. Today, we're getting into something really quite different, MTR.
Right, the multitronic operating realm.
Exactly. And its reference implementation, RENTAHAL.
Yeah, it's definitely pitched as a potentially, revolutionary way to think about computing,
Huh.
especially with AI.
So our plan today is really to unpack this. We want to understand the core ideas, what it's supposed to do, maybe its potential impact.
Exactly. We've got the docs, the code.
Hmm.
It's a shortcut, really, to get a handle on what seems like a pretty complex, ambitious project.
Yeah, we've looked through the main PDF, MTOR, the OS, and some of the the setup guides.
And it's ambitious, right? That's the word.
Definitely. It's not just tweaking things. It feels like a fundamental rethink of AI orchestration, maybe even core OS ideas.
And all in Python, which is a choice,
Bold choice, yeah. That whole throw everything in the trash, start fresh mentality.
right?
It's, interesting.
Absolutely. And the first big idea you hit is this concept of intent-based computing, which is like a real shift from how we usually interact with computers, command-driven versus intent-driven.
Right. So instead of telling it how to do something step by step,
You tell it what you want, what you intend to achieve. MTR is designed to figure out the how.
so how's that different from, say, my current OS? My phone, my laptop, they manage resources, apps.
Well, yeah, they manage resources based on commands from apps. MTR aims higher. It's about managing the intention itself.
Hmm.
The docs lay out this flow. User intent goes to this universal broker,
Okay.
which finds a specialized worker, gets the job done, and gives you the result.
So less clicking icons, more computer, do this thing for me.
Kinda, yeah. Think of your OS now as a really good foreman following blueprints exactly. MTR is more like the architect who understands the goal of the building.
Okay, I get that. There's almost a philosophical angle, isn't there? Making tech serve the intent better.
Totally. And the architecture seems built for that.
Right.
This universal broker thing is key.
The air traffic controller, you called it?
Yeah, exactly. Stateless, event-driven. It just directs the intentions.
And how does everything talk to each other?
WebSockets. Using JSON messages. So a standard way for all the parts to communicate.
Right, okay. And then there's an intent router.
Yep. That's the bit that figures out what the user's intent actually is, classifies
Figures
it.
it out.
Yeah, sends it to the right place. Then the worker management system keeps tabs on all the actual doers, the workers.
Checks if they're busy, if they're healthy.
Exactly. Routes the intents based on who can handle it best right now.
And the safe queue system. Is that just for handling lots of requests at once?
Pretty much. Like avoiding traffic jams. Make sure concurrent requests get handled smoothly. Don't crash the system.
Okay. And it aims for a consistent interface, whether you type, talk, or show it something. Multimodal.
That's the idea, yeah. Text, voice, vision, same underlying system, handling the intent.
So MTOR is the big idea, the framework. RENTAHAL is the proof of concept, the first version.
Exactly. RENTAHAL is described as the first, complete implementation based on MTR principles.
And its goals are?
Transparency, safety, and interestingly, public ownership. That seems quite central.
How's it built, technically?
It's a fast API server on the back end. It integrates AI models, Whisper for speech to text, Bark for text to speech.
You're right.
Uses WebSockets for that real-time feel. And yeah, it even has the computer wake word. Very Star Trek.
Ah, yeah. And the licensed GPL3. Plus that internal openness, no patents allowed clause.
Yeah, that really doubles down on the community open source ethos. No locking it down later.
Definitely sends a message.
It does.
Yeah.
And looking under the hood of RENTAHAL, the design seems quite layered. You've got the front end, the back end logic, and then the worker pool doing the heavy lifting.
And it uses things like Asensio and fast API. That's for responsiveness.
Yeah, asynchronous processing. It means it can juggle lots of requests at the same time without grinding to a halt. It makes it feel fast.
Okay. And you mentioned stateless queries. What's the benefit there?
Right, each request is sort of self-contained. It carries all the info it needs. It uses a query model. It means the system doesn't need to remember the history of every interaction to process the current one.
Which makes it more robust, easier to scale.
Exactly. Less chance of things getting tangled up. If one request fails, it doesn't necessarily mess up others. Fault isolation, scalability, big pluses.
And it pulls in a lot of different AI models. Hugging Face models, Claude, Stable Diffusion for images, Whisper, BARK.
Yeah, it's like a toolkit. It can handle text, speech, images, makes it versatile.
And it's all tied together with an event-driven architecture, so it reacts instantly.
Pretty much. Like notifications, things happen, events fire, the system responds. It's not constantly polling anything new.
Oh,
more efficient, more real-time.
Okay, now the elephant in the room, perhaps.
Yeah.
Using Python for something they're framing as an RTOS, a real-time operating system.
Right.
Python has, the GIL, garbage collection.
Right.
It's not typically the first choice for hard real-time tasks.
Definitely a fair point. And the documentation addresses this head on.
How do they argue they get around it?
Well, through the design.
Yeah.
Things like the health-based load balancing, only sending work to workers that are actually responsive.
Okay.
Configurable timeouts, so one slow task doesn't block everything. The stateless message passing simplifies coordination. And using WebSockets is efficient for communication.
So they're architecting around Python's potential bottlenecks rather than relying on Python itself to be inherently real-time.
That seems to be the approach, yeah. Managing the flow, ensuring responsiveness through the overall system design, not just the core language speed.
And they draw a parallel between MTOR's async event loop and an RTOS scheduler.
They do. It's an interesting comparison, managing asynchronous tasks versus scheduling real-time processes. Similar goals, different mechanisms.
Let's dig into what RENTAHAL can actually do. Multimodal interaction sounds cool. Voice, text, vision.
Yeah, it's designed to be flexible in how you interact. The voice stuff seems quite prominent, the wake word, speech in, speech out, using bark.
And the real-time aspect comes from those WebSockets again. Makes it feel immediate.
Supposedly, yeah. That's crucial for voice interaction, isn't it? You can't have long delays.
And scalability, you mentioned dynamic worker pools. Local remote via something called Grok.
Yeah, Grok is a tool that lets you expose a local server to the internet. So RENTAHAL can use workers on your machine, or it can connect to workers running elsewhere, maybe someone with a powerful GPU like an RTX card.
Ah, so you could distribute the workload.
Exactly. And it's got this self-bootstrapping thing, sets up its own database, creates an admin user automatically on first run.
Handy. Saves setup hassle. What about developer tools? Debugging.
Yeah, automatic debug logging, a dedicated debug window, system usage tracking. It seems quite developer-friendly in that sense, monitoring, seeing what's going on.
Makes sense for an early stage project, and there's real-time communication from the SecSup to users.
Apparently, yeah. The admin can send messages directly through the interface.
What else can the admin do? Sounds like quite a bit of control.
Oh, yeah. Managing the AI models, pulling new ones from Hugging Face, maybe configuring Claude, adding or removing those remote RTX workers we talked about.
Banning users. Stopping tasks.
Yep. Banning users, terminating queries that might be stuck or malicious, sending system-wide messages. There's a GUI for a lot of this too, apparently.
Wow, okay. Pretty comprehensive. And it connects to external stuff. Gmail, weather.
Yeah, integrations with external APIs, so it can pull in outside information or potentially act on external systems.
And handles audio beyond just live speech. Pre-recorded stuff. Text-to-speech.
Right. Supports different audio inputs-outputs, including that BRK model for generating speech. And there's vision processing capability mentioned too, though maybe less developed currently.
So it feels like a working platform, not just theory. What about scaling it up? Decentralization. It's meant for large AI compute realms.
That seems to be the design goal. The dynamic worker pools, the health monitoring, that's all built for handling variable, potentially large loads.
And using those remote workers via NGRK points towards decentralization, right?
Definitely. It allows for a distributed network of compute resources. Combined with the eternal openness license, it paints a picture of a potentially community-run, decentralized infrastructure.
Okay, applications. The docs mention things like robotics, device swarms, even spacecraft. Seems ambitious.
It does. The argument is that the real-time processing, the voice vision capabilities are relevant there. Robots need to react, perceive, swarms need coordination, spacecraft need autonomy.
But it also flags limitations, right? Like no direct hardware control for sensors or motors yet.
Exactly. It can process the data, but it doesn't have built-in interfaces for, say, reading a LiDAR sensor or controlling a robot arm directly. That layer isn't there yet.
Same for factory automation. It could use IoT data, but lacks native industrial protocols.
Right. No native Modbus or Profinet support, for example. It would need adapters or middleware.
And for critical things, spacecraft, safety-critical factory stuff, it lacks redundancy, specific safety features.
Yeah, those are pointed out as areas needing development for those high-stakes domains. No fault-tolerant hardware support or safety certifications are mentioned.
And specifics for robotics, like motion planning or swarm coordination algorithms.
Not explicitly included, no. Those would be applications built on top of MTOR, or features needing integration. Same for factory stuff like PLC integration or complex scheduling. It's a foundation, but specialist tools need to be added.
Okay. One of the really big claims is around resource efficiency. How does MTOR supposedly save energy?
This comes back to the core design. On-demand computation only using power when actively working on an intent. And zero-state maintenance not constantly keeping things alive in the background.
So less idle power consumption.
Potentially, yeah. And the document projects massive savings from this hundreds of terawatt hours globally per year if widely adopted.
Wow. Hundreds of terawatt hours. That's huge.
It's a very optimistic projection,
Yep.
but the underlying principle makes sense. Less constant activity means less power draw in data centers on your own devices across the network.
Plus knock-on effects like needing fewer raw materials for hardware, less cooling.
Exactly. Reduce the primary energy use and you reduce the secondary impacts too.
Are there specific examples of this efficiency?
Yeah, they touch on video streaming, like
Huh.
just-in-time processing, adapting quality dynamically, distributing the work. Could mean less server load, less bandwidth, less power used by your phone or TV.
Okay. Gaming, too.
Yeah, the idea of distributed game processing. Offload the heavy computation from the player's device. Could allow complex games on simpler hardware, saving energy.
And music services, how would that work?
Things like environment-aware playback adjusting based on where you are, more efficient streaming protocols, maybe more processing done locally or distributed differently, small gains adding up.
So it's about smarter resource use across the board. But how would we actually get there? Transitioning seems like a massive job.
The docs suggest it could be gradual. Maybe start with an intent routing layer on top of existing systems, or replace components one by one with MTOR-based equivalents, or run a hybrid model. Some things on MTOR, some on the old systems.
And then there's the full rent-a-HAL approach, build it from scratch using that as a template.
Right. But they do acknowledge challenges.
Yeah.
Initial latency, the first time you ask for something new, it might take a moment to spin up the right worker. And the learning curve for developers use two traditional methods.
How do they suggest tackling those?
For latency, maybe predicting user intents, preloading workers. For developers, good documentation, training the usual stuff when introducing a new way of thinking.
This whole thing, MTO and rent-a-HAL, it feels significant. They ask if it's PhD level work. What's your take?
When you look at the theoretical side, the MTO framework itself, this idea of a browser-based real-time AI OS, that's quite novel. Then you look at RENTAHAL, the layered design, integrating all these different complex techs like FastAPI, WebSockets, multiple AI models, the async stuff. It's technically sophisticated.
The scope is huge, too. It's not a small utility.
Exactly. The ambition, the scope, the technical depth, the detailed documentation. It ticks a lot of boxes typically associated with advanced research, like PhD work.
Even if it's still early days.
Absolutely. It's a foundation. But the innovation and rigor seem to be there. Future development would build on that.
The document also has these, personal reflection bits, the author deciding to throw everything in the trash after a long career.
Yeah, that's quite a statement, isn't it? Suggests a real belief that a radical change is needed.
And using AI itself in the development process, that's very meta.
Very much so. An AI-engineered approach to building an AI orchestration system, and the self-description as the test grunt mule that shows real hands-on commitment.
Finally, those symbolic tributes, a GPU named after you, a spacecraft named after you, how do they connect?
Well, a GPU one ties directly into the RENTAHAL architecture, right? Using remote RTX workers. It symbolizes community-contributed compute power.
Ah, okay. Makes sense. And the spacecraft.
That links to the potential applications we discussed. MTOR's real-time, decentralized nature could be adapted for space-controlling probes, satellite networks. It's aspirational, but connects to the system's potential capabilities and the community aspect, maybe inspiring projects like CubeSats.
Right. So wrapping this up, MTOR and Rento seem like a really bold, community-first attempt at building AI systems differently. Focus on intent, big potential for efficiency, built to scale.
Yeah, I think that's a fair summary. Hopefully you listening now have a much clearer picture of what this project is all about, the concepts, the tech, the goals, the potential.
And maybe it gets you thinking, what if technology really did focus more on understanding your underlying intent? How would that change things? Could this be a path to a more decentralized, maybe more efficient AI future? If you're curious, definitely check out RENTAHAL on GitHub.
Absolutely. And if any particular part grabbed you, the licensing, the async architecture, the efficiency claims, a specific application, dig deeper. There's clearly a lot there, and it feels like the project is just getting started.